All right, we're going to go ahead and do Bridge Math, Semester 1, Unit 5.3, and I believe it's the same in Algebra 2. Algebra 2, Semester 1, 5.3. It's Synthetic Division. Algebra 2, I'm not certain on, but it's definitely Bridge Math 5.3. The example problems that I'll be using are from page 9 um, in Bridge Math Semester 3, 5.31. Um, Now, what we're going to talk about is synthetic division, so what we want to talk about is where this is all going and coming from and what we're getting out of it. There we go. All right, so let's get started. So we have our Cartesian coordinate plane, and what we're looking at is when we do synthetic division, we're looking to see if the number that we're testing, the factor that we are testing, if it is in fact a root or a factor. And what a root is, a root is where the graph crosses the x-axis. So where those orange circles are is where the graph is crossing the x-axis. Now, synthetic division can tell us algebraically if a number is a root, if a number is a point on the graph where it crosses the x-axis. So that's what we're looking for. In general, that's what we're looking for. All right, so we're going to go ahead and do our first example. Um, we're going to go ahead, well, we have a polynomial x cubed minus 2x squared plus 2x minus 15 divided by x minus 3. We're going to go ahead and set up our synthetic division setup, I guess. Apex does it a different way. I prefer this way. You are free to use however you like to organize it. I am just always going to use my way. Um, it's the way I was taught. I'm going to stick with it. So we're going to start with the divisor with the x minus 3. Now, what we need, we're not going to use the x minus 3 directly into the problem. What we need to do, because x minus 3 is in factored form, I'm going to set it equal to 0, and then I'm going to solve for x. So I add 3 to both sides, and I have x equals 3. Now, that would be my root. If x minus 3 is a factor, then x equals 3 is a root. Now, we do not know if it's a root or a factor yet. That's what we're about to test and find out. So we just take that divisor and we take the opposite. So as x minus 3, the opposite would then be a positive 3 because roots and factors are always opposites. So 3 goes out there. Now I'm going to find the coefficients of the numerator polynomial. So we have a 1. There's no number in front of the x cubed. We always call that a 1. And then I'm going to take the entirety of negative 2, including the negative, and that's my next coefficient. I then have a positive 2 for my third one. And then my last one is a negative 15. Again, I'm taking the negative. So what I did, I just took the coefficients and I wrote them out. So you can see with the different colors exactly where they came from. Now what I'm going to do is I'm going to go ahead, I'm going to do the synthetic division steps. My first step is I take that first term, that first thing, and I'm bringing it down. All the way down underneath. Got to clean that up a little bit. There we go, is a 1. Now, the first step, or the next step of synthetic division is multiplication. 3 times 1. 3 times 1 is 3. I put it up here underneath in the next column, we'll say. And then I'm going to go ahead and add them up. Negative 2 plus 3 is going to give me a positive 1. All right, so I just added. Now I'm going to go back to multiplication. I'm going to go back to that 3. I'm going to be using that 3 often. So 3 times 1 is 3. I'm then going to add again. I get a 5. And again, I go back to that same thing. 3 times 5 is 15. There it is. I'm going to add, and I got a remainder of 0. Now, let's talk about what all this stuff is. We took, or we got it all, I guess. So we took the x minus 3, and we solved it. We set it equal to 0, and we solved for the opposite, and we got the 3. We took the coefficients of the numerator and plugged them in. So we got the 1 there, the negative 2, the positive 2, and the negative 15. I plugged them directly in. And then what we did is we went through our synthetic division steps. I dropped the 1 down. That's my first thing, because it brought it all the way down. And then I multiplied. And let's go ahead and change the color here and get a little pink here. That's something obvious. So we're going to take this 3. It's 3 times 1, and I brought it up there. And then I'm going to go ahead and add, and I bring it back down. And now I'm going to take that 3 again and multiply through the 1, and it goes up. and then I bring it down again after I add, and then I multiply. I don't really like the lines, and then add again to bring it down. I don't really like the lines, kind of clutters it up, but I'm just trying to show you where everything comes back to that 3. We multiply, then we add inside, but to get inside, we have to multiply, we have to use that 3. So, and then you can always rewind the video to go back to when it was cleaner. Um, but you can see it kind of just goes directly through it. So now let's go into the setup where everything came from. So we knew that that 1 was my x cubed, and the negative 2 is my x squared term, and the 2 was my x term, and that negative 15 was my constant. Now, because I'm dividing, right? I'm making it smaller. When I divide the x cubed, it's going to become an x squared. When I divide the x squared, it's going to become an x. And I'm going in sequential order. So I had an x cubed, so 3 to 2 to 1 to a constant, which is technically x to the 0 power. And then when I divide that, my answers on the bottom row just drop by 1. So x cubed becomes squared becomes x, and x becomes my constant. And then that last number in my answer is my remainder. And in this case, we got a remainder of 0, and that tells me that x equals 3 is a root, and x minus 3 is a factor. And that's because I got a remainder of 0. A remainder of 0 gives you a factor and gives you a root. And so on this graph somewhere, I don't know what the whole graph looks like, but somewhere on this graph, however it goes up or down, I'm not sure, is going to cross at positive 3, because that's what we discovered, that this crosses at positive 3. And so my answer would be just a 1x squared plus a 1x plus 5. That's what happens when we divide the x cubed minus 2x squared plus 2x minus 15 divided by x minus 3. Go through all, and this is a whole bunch of blah, but it's consistent. Bring it down, multiply, add, multiply, add, multiply. And then we have an x cubed. I subtract 1, I get an x squared. The remainder is 0. That means it's a root. If the remainder is not 0, it's not a root. Should we time to head over to the... So again, we had the positive 3 by taking the opposite of the x minus 3. And then we took all the coefficients and plugged them in, the 1, the negative 2, the 2, and the negative 15, and brought it all down. Now we're going to go ahead and set up this next problem. So the first thing we're going to do is we're going to set up our synthetic division. So just a little 90-degree angle, kind of, supposed to be at least. And I take this x plus 2. I want the opposite of x plus 2. So I could just think about it, or I'm going to go ahead and write it down. X plus 2 equals 0. Subtract 2 to both sides, and I solve for x. X equals negative 2. That's what goes outside. That's my divisor. I'm then going to identify my coefficients of everything inside. So I have a positive 2 first. And then I'm going to have a negative 1. Right? It's just a negative x, but again, if there's no number written down, it's got to be a 1. And then we have a negative 10. So I've identified all my terms that go in there. First step, I bring that first term down. So I bring the 2 down. And now I'm going to multiply. Negative 2 times 2 is negative 4. I'm going to go ahead and add. Negative 5. All right, now I got to go back. Go back to that same thing. I got to multiply again. Negative 2 times negative 5 is going to be a positive 10. I add them up, and I get 0. So I got a remainder of 0. That tells me that x plus 2 is a factor. That tells me x equals negative 2 is a root. So by doing this division and getting a remainder of 0, it tells me if I have a root and have a factor. That tells me that this equation, when it's graphed, will cross the x-axis at x equals negative 2. And then we know that it was a 2x squared, so when we divided, that becomes just an x term. We had an x term, which when we divide it becomes a constant term. Always goes down by 1. So the answer to this problem was just 2x minus 5. And then we know that x minus 2, x plus 2 is my factor, and x equals negative 2 is my root. Now for the third example, again, we're going to start the same process. I'm going to go ahead and set up my synthetic division. Now I'm not going to write out x minus 1. I know that I need the opposite, so I have x minus 1. I know it's going to be a positive 1. Mess around with colors here. All right, now we're going to go ahead and identify my coefficients. Again, there's no number in front of that x squared. We don't see it. We know it's got to be a 1. Now I have my -5 and I have a +2. And now I'm going to solve it. Bring my first term down. That's my first step. I always bring that first number down. That's a 1. And then now I got to multiply. 1 times 1 is going to be 1. I go ahead and I add now. -5 plus 1 equals -4. I'm going to multiply. 1 times -4 is -4. Now we have a remainder of -2. So now this is the first problem where we didn't get a remainder of 0. Well, that's okay. Doesn't bother me. That just tells me that it's not a root. It is not a factor. I didn't do anything wrong. It's acceptable to not have a root, to not have a factor. Not everything's going to be a root. Not everything's going to be a factor. So we have x squared. Again, so we know that that 1 was the x squared, the -5 was the x. So when I divide, my first term is going to be an x. So I have a 1x. And then my constant is a -4. And then -2 is my remainder. That tells me that the x plus 2, or sorry, the factor wasn't a root, which is fine. Or that wasn't a factor, wasn't a root. We're going to do one more example just real quick here, just to prove a point here. We have 3x cubed plus 4x plus 3. I'm going to go ahead and set up my synthetic division. I got to give myself a divisor. So I have an x plus 1. Again, I'm going to take the opposite of x plus 1. That's going to be a -1. All right, so I put that out there, and I'm going to take all my coefficients. So I have a 3, I have a 0, I have a 4, and I have a 3. Cool, great. Do you know now? And you know where everything came from, right? Well, no, of course not. Where did the 0 come from? Where did that 0 come from? Why is it there? All right, do you have any guesses of why that's there? Well, it's there because, as you can see, the 3 was an x cubed, the 4 was an x, and the other 3 was a constant. The term that we're missing is an x squared. We went from x cubed to x. We missed a step in between. So because we missed that step in between, we had to put in a placeholder, we'll call it. All right, so we put that placeholder in there. That's that 0. And then we can just solve the problem the exact same way. So it doesn't change anything in terms of our problem. All right, we just need to add that placeholder in there. If there's ever a term missing, we add it.